Okay, hopefully everybody can see that okay. Um, so, uh, all right. Yes, I'm assuming you can see my screen. Okay, so hello, welcome. My name's Kito, and thanks for coming. I'm glad you could make it to JCon World. I'm very excited to be here. I'm also a member of the content board, so I had a hand in at least reviewing some of the other sessions here. So this session is called Services Reloaded, and what we're going to be talking about is the benefits that you get from Project Loom, which is available in the latest version of the JDK. So first, I just want to tell you a little bit about myself. So, as I said, my name is Kito. I'm the principal consultant at Virtua, where we do architecture, mentoring, development, training, etc., around Java microservices, Jakarta EE, web components. So we do some front-end work as well, and just general software development process and all sorts of fun stuff like that. I'm working on a project called speakertracks.com, which is a site that helps speakers plan and manage sessions and presentations and things like that. So if you're interested in that, check that out. My company is also a partner with Prime Tech, which has a whole bunch of open source UI libraries for React, Vue, JSF, Prime, and Angular as well. I wrote a book a long time ago. If you like podcasts, I encourage you to check out the Stack podcast. You can find it at stackpodcast.com. We talk about just enterprise development, front-end, back-end development. We have lots of guests on, and it comes out about every month or two. So if you like podcasts, I encourage you to check that out. I'm a Java champion, a member of the Jakarta EE Ambassadors Council, and other things as well. And also, I speak at a lot of conferences, obviously. All right, so that's enough about me. I'd like to hear a little bit about the other people on the call. If you could, in the chat, if you could just let me know sort of what your background is, like do you do reactive development, or have you built reactive applications on the Java server side? Or are you just curious about virtual threads? Have you used virtual threads before? Those sort of things. So put that in the chat. I'd love to see it. All right, Reactive is baked into a lot of libraries that Stefan uses. Oh, come on, someone else has to have something to say. Okay, someone's curious about the possibility of virtual threads. Excellent. Okay. Okay, so Stefan uses Quarkus, Kafka, REST libs, etc., and they have support for virtual threads, or Reactive, excuse me. Someone has a little bit of experience with Project Reactor. Thank you, Samuel. Okay. So I guess that's a reasonable sampling of the audience. So thanks for your input. Appreciate it. All right. So like many of my presentations, I like to start with a little bit of history. Uh, let's go on a Java thread journey. Okay. Let's take a look at sort of the history of Java and threads. So let's start with the idea of green threads. If anyone remembers green threads, can you raise your hand? Are people allowed to raise their hands here? I'm not sure if that works. Let me see if I can be more here. Okay. I don't know if people can raise their hands or not. But oh, there is a raised hand. Okay, Stefan's too young for that. Yes. So I remember the very early days of Java, and there was something called a green thread. And green threads were in the initial versions of Java, JDKs 1.1 to 1.2. And the idea with a green thread was that each thread had several green threads. So each platform thread, each operating system thread has several green threads. And basically the idea was that for any number of green threads, there was like one thread that was scheduled for them. And that's how it was for the first few years of Java. Now they realized pretty quickly that that wasn't terribly performant back in the day, because you have to remember back then, we didn't have CPUs with dozens of cores, right? It was more like a few cores, maybe. Maybe you had a dual core machine. That was a big deal, right? So it turns out that they decided to go to platform threads, right? So then, and that's what we had for the next few years, for 2000 to current. So each Java thread maps directly to an OS thread. There's one-to-one scheduling. It's very straightforward. And any blocking that happens with your thread usually happens at the OS level, right? So basically what happened when we started building applications, building server-side applications, because you have to remember the early days of Java, actually, we had applets, which actually ran in a web browser, which is kind of hard to believe these days. But once we started building server-side applications, we had the Servlet API. And the Servlet API is synchronous, right? Each incoming request maps to a single thread in Java, which then maps to a single operating system thread. So it's pretty straightforward, and allows you to do very interesting things like have thread local variables and things like that that actually map directly to the thread of the incoming request. And so a lot of the applications we had initially were built on the Servlet API using Tomcat or Jetty as the server container, using a web server like Apache. That was pretty much the standard, right? And you used Apache for serving other resources. And all of these basically had each incoming request go to a single thread. Pretty straightforward. But what I think some people realize is that the scalability of these systems built, using a single thread mapping was limited, right? And as the internet got bigger, applications need to be able to handle more users. So Nginx came out in 2004 with non-blocking I/O. And the idea with Nginx was that essentially they wanted to fix the 10x problem. So basically, they wanted to increase the scalability that they had that we kind of maxed out with Apache. So they called it the C10K problem, which was a scalability issue that prevented web servers, even Apache, from handling more than 10,000 concurrent requests. So that was basically the goal of Nginx. And the idea there was to make non-blocking applications, right? So your request came in and it handled the thread scheduling such that you could get more throughput because you weren't blocking as much, right? So you could handle more requests. And since each thread wasn't mapping directly to an operating system thread, you were able to achieve more throughput. So this was in 2004, and this is partially why Nginx became so popular, right? And then what happened after that is we had lots of other server platforms that had a similar sort of approach. So Netty came out in 2004, which is Java-based, Node.js, of course, 2009, Akka in 2010. And Vertex came out as well. And that's actually built on top of Netty, but again, it's an asynchronous. So the idea here was that you could take the incoming request and then you could handle sort of correlate things via events and streams and things like that. And that's how a lot of these servers work. Right. So in 2013, Servlet actually added async support, which is nice. So Servlet actually supports async as well. It's not available in JAX-RS, which is, or Jakarta RESTful Services, which is used for a lot of REST applications. Although most servers now have reactive bindings for that kind of stuff anyways. So then we had the reactive manifesto. And the idea with this was to basically try to achieve a few different things. So, and of course, scalability was one of them. But we also wanted to make sure the applications were responsive. So by this, we mean that we're not blocking when we don't need to be, right? So we can respond as much as possible, as much as we can. We also wanted to make sure the systems were resilient so that they stay responsive in the face of failure. So by handling things in a reactive way, you could theoretically not have your whole system fail, but make sure that the whole system stayed up and running, but only handle failures in a locally contained fashion. We also wanted to make sure they're elastic so they can stay responsive under varying workloads. So whether they have 3 requests or 3 million requests. Of course, obviously, the million would scale a lot, but And also another key point is that they're message driven. So, and this is very common in reactive frameworks, is that they do a lot of message passing to enable all of the throughput that they support. So once we got past the server level, we ended up with a lot of different frameworks. So ReactiveX is one of the big ones. And from that, we get .NET implementation, we get RxJS, RxJava, and several others for different frameworks as well. And then, of course, we get it at a more higher level, sort of integrated with the application frameworks that we use, right? So we get Spring Project Reactor, we get reactive streams, it gets a Java 9 reactive streams, which is the flow interface in 2017. So these features are slowly making their ways back into the platform. And we also get Small Ride Mutiny, which is a Red Hat project. We get all those fun things. So here are some other sort of core reactive concepts from like sort of the ReactiveX world, right? So we have the idea of an observable, and then you'll find this in pretty much any reactive framework, right? So you have the idea of an observable, which basically subscribes to events. So you have some object that subscribes to events, and it basically reacts on whatever item is returned from a stream, essentially. There are also operators. So the operation that you apply to each element in a sequence, it can change, right? So you can chain them together. So you can have different operators that you apply. And also they all have the idea of a single, which is something like an observable, but instead of having like a series of values that are being emitted, you only have one. And so it basically gives you a way to treat a single item the same way you treat a set of items. And then you also have a subject, which is sort of a bridge or proxy that lets you sort of map between an observable and the rest of the world of normal programming. All right, so those are just some of the basic reactive concepts, and of course, you need to be able to schedule all these things, right? So you need to be able to ensure that there's something that's controlling how those items are being added, are being observed essentially, and how that's managed. So all of these are different sort of reactive concepts that if you do build reactive applications using these APIs, you need to get a handle on. So there are different frameworks that, of course, let you do this. And one of the people on the call earlier said that they were using reactive services through different frameworks. So Quarkus would be one. And all these are good services for building Java services, or good framework for building Java services. So Quarkus is one. Spring Boot using Webflux works. Vertex is another one. Micronaut is another one. All these have different support for reactive features. And if you take a look at Spring Boot, I think this is a really good picture. This is from their site. So on the left-hand side, you have the reactive stack, or on this side, I should say, depending on which way you're looking. So we have the reactive stack here, right, which is Spring Webflux. And you see internally it uses either Servlet 3.1 using the underlying async support, or Netty, which is built from the ground up for reactive. It uses reactive stream adapters, Spring Security Reactive, and of course, Spring Webflow framework on the top. And then the Servlet stack uses a traditional Servlet container, Servlet API, and Spring Security, normal Spring MVC, et cetera, et cetera. So this sort of gives you an idea about how they're different. So basically, if you do reactive, you got a different programming model. And if you do Servlet, you have your sort of normal single-threaded model. And remember, the idea with reactive is that you get increased throughput, right? It's not necessarily that you get things running faster, but you can scale better. And that's the main benefit. So if you have a reactive app with Spring Webflux, it looks kind of like this. So you have this core Flux object, right? And this is a normal Spring BC controller, right? And we have this method here. So this is a very simple endpoint. And instead of returning a coffee object, because it's returning coffees, right? It is actually returning a flux coffee, okay? And basically, you'll find most of the reactive APIs work like this. It's like instead of returning the object, you basically return a wrapper around the object, and that wrapper is essentially an observable. It's a stream that you can operate on. We have coffee ops, right? Which is this operations class up here, right? And that is going to basically provide all of our, it's basically the stream of different coffees. We're going to grab the keys from it, we're going to do a flat map, and then we're going to do get a value, essentially, return that. So this is obviously a very simple example, but the main difference here is that we now have a different type we have to worry about, and we are definitely working streams, which is really not a bad thing because streams are really powerful, right? So that's an example with Spring WebFlux. With Quarkus, it's a similar idea. It uses Mutiny for its reactive support. And this example actually is using the GraphQL API in MicroProfile, which is used by Quarkus, but it's still the same idea, even if you're doing a normal REST endpoint. Excuse me. So you see we have to grab this uni, which is a single object. And then we've also got the it's not listed here, but it's also the source, the type that we need for multiple records. Okay, so here's our queries. This is sort of the main entry point for a GraphQL service. And we're calling this little find method here, which is going to basically just grab it. So this is the utility method, which we'll look at in a minute. But you see, again, we're returning the uni object here. And we've got a couple other methods here that return unis as well. And this one actually returns a uni, but is also a list. So it's basically like a single object with a list inside of it. So, the programming model isn't terribly different at this level, right? But this is basically how the reactive APIs generally work. But the problem with reactive is that it's like anything else. It's like a great idea, but it runs into a few issues. So obviously the main issue is that you have a different return type to worry about. And you also need to ensure that all of your code is non-blocking for it to work, right? Because essentially what you're doing is you're not using the platform threads. You're not using the basic Java threads. Any code you have anywhere that's using a normal platform thread or a normal Java thread, which maps to a platform thread, is going to block. So you won't get the benefits that you would with reactive. So the code sometimes can be hard to read. And in this case, as I showed you, it wasn't hard. But as you get deeper and deeper, your code can get kind of complicated. So this is an example. This is actually from our speaker track application. So we have this queries class, right? And we have this utility method called fetch. And you see what it's returning is a base entity, which is a uni, right? We basically are grabbing a value. We need to get it from a parent object. This is basically grabbing a child object, essentially. And down here, this is sort of the main code, right? We call, and also what Quarkus has is Hibernate Reactive. So that's essentially what you use for persistent stuff if you're using a relational database. So you have Hibernate Reactive, which also has integration with all the same APIs, with Mutiny and everything. So you return a database, you do with transaction, you throw in the session object, which is the reactive session. And then you got to do some work here. And then when you call find, you can pass in some more, the ID, and then you can then chain calls. So this is the idea of using different operations, okay? And you can do all that stuff. And then down here, we have some utility methods. This is the method for getting a list of objects, which is pretty straightforward. You do a session, and then you call the find method. So this code isn't super complicated, but as you get deeper, the code can get more complicated and hairy to look at. And the main thing is that you have what are called leaky abstractions, right? So basically, You as a developer don't care whether it's a uni or a list or or what. You're trying to return an object. You're trying to return your domain object, but all of your code is now leaking with the types required for the reactive APIs. So things have gotten a little more complicated, right? And your code is essentially littered with all these different abstractions. The other issue with reactive development is that these stack traces are hard to read, right? So you basically, because everything is not running in a single thread, the stack traces don't really tell you what's going on. Now, there are ways, especially with Spring Web Flux, to add special operators to give more context. So when you get a stack trace, it actually is useful. But that doesn't always, you have to know what you're looking for. You have to know what API calls to use. And the reality is not everyone's going to do that. So you do have a little bit of overhead there with stack traces as well. So fast forward to this year, Project Loom virtual threads have dropped in JDK 24. And the question is, what does this actually mean to you as a developer? And how does it relate to all this reactive stuff that I was just talking about? Well, basically, basically, number one thing is, well, let me actually take a step back. Let me tell you what they are. So Project Loom is one of many projects that are part of the OpenJDK, right? And it's called Project Loom Fibers Continuation and Tail Calls for the JVM. And so, like most projects that are part of the OpenJDK project, there can be the project, and then there's also a specification or a proposal, which is the JEP. But a project can have multiple JEPs. It doesn't have to be just one thing. So what we're talking about when we talk about virtual threads, we're talking about the first major piece of Project Loom that's actually been released. So that's why I'm calling it the fruit of the loom. So it's essentially the first fruit of the Project Loom. So the project itself talks about fibers, continuations, and tail calls for the JVM. So if you unpack this, like if you look at the JEP for virtual threads, this one right here, 444, there's no mention of fibers or continuations or tail calls, right? But that's the name of the overall Project Loom. So fiber was the initial name for virtual threads. So a fiber is a lightweight thread, which we'll talk about in a minute. A continuation is basically a sequence of constructions or a coroutine that can yield and then be called at a later stage. So this is actually happening because that's what's happened with the virtual threads. Tail calls is a tail call is basically recursion. It's the idea that you can optimize recursion. That's what they're talking about here. So if you have a recursive method, the compiler can actually turn it into an iterative method and then make it more efficient from a compilation level. This is actually already taking place in other languages like Scala and Kotlin, and this is not actually part of virtual threads. This is like another feature of Project Loom that isn't out yet. So if you're wondering about the name, that's sort of the story there. Now, in terms of what you actually get, is you get support for real virtual threads, which I'll talk about in more detail. But this project actually started in 2017. And to me, it's a really good example of sort of the thoughtful effort that goes into building the Java platform, because these several years later, right? So what happened in all that time? The first preview ships was JDK 19. So we've had a couple releases that play with the virtual threads over time. So it's been out for a while. The main feature, of course, is the end-to-end schedule, right? So we talked about green threads earlier and how there were M to 1, right? So you have X number of green threads and they map to one thread. So with virtual threads, it's a little more complicated, right? Because you can have multiple cores, right? You can have many threads on your operating system. So you have end-to-end scheduling. So you basically have M number of virtual threads mapping to N number of platform threads. So this is easily visualized by this picture. So you have your JDK scheduler. So now the JDK is actually handling and scheduling your virtual threads, whereas before it was all handled by the operating system, right? And you have the idea of a platform thread, which is handled by the operating system, right? And then you can have X number of virtual threads. And your platform thread can be a carrier for a virtual thread at any point in time. So these are also called carrier threads. And this is basically the way it works. And what this does is it allows you to have lots of different threads running, lots of virtual threads. And then the platform, they get mapped with platform thread. And then whenever they block, whenever there's no platform thread available or when there's IO involved, right? And there's really no technical limit. You can have as many virtual threads as you want. Obviously, your throughput will decrease if you have way too many virtual threads. But this gives you a lot more flexibility. And what's nice about this is that it's all handled at the JVM level, right? So you as a developer don't have to really do much extra. There's a little bit of extra you have to do, but not a whole lot. And the JVM takes care of all the scheduling and all that kind of fun stuff. So all the hard work is handled at the low level, and you get to concentrate on the application code, which is nice. Now, there is possible for a virtual thread to be blocked, okay? And this can happen, and we call this being a pin thread, so hence the pin there. So if a virtual thread gets blocked, it can be pinned, and of course, it can be blocked on IO and things like that. And of course, you actually want to, I should take a step back. So you want to avoid this happening too much. So you kind of want to avoid scenarios where you're actually pinned to a thread, because then you're, of course, losing the ability to use that thread. So what we want to do, of course, if you are using virtual threads, is avoid any issues that might come up. So there's a few caveats. You don't pull them because there's really no reason to pull them. When you pool resources, you are pooling what are essentially expensive resources, right? You pool threads, platform threads, not virtual threads. You pool database connections. You pool other sort of connections that are expensive, right? But virtual threads are not expensive, so you should not pool them. You have to be careful with thread local variables. They're a little bit different with virtual threads, but they are still supported. And you also need to be aware when code pins a virtual thread to its carrier thread. And this can happen in the case of static blocks and synchronized blocks and things like that. So you want to try to avoid those things because they essentially are pinning your virtual thread to a carrier thread. JNI for foreign functions is not, JNI or foreign functions are another area you should try to avoid. So the APIs for virtual threads are very similar. You can get a virtual thread from an executor, from the executor service, essentially. So we say executors.new virtual thread per task executor. You can get one there. And what you get is actually a normal thread object, right? So when you do this is actually normal Java code. There's nothing special about this. The only difference is that your executor was different. So the APIs are pretty much the same as what you're used to. You just need to make sure you have a different executor available. There are, of course, some other special methods. So you can also create a virtual thread this way, thread of virtual, right? And there is also thread.start virtual thread if you want to start a virtual thread instead of a regular thread. So this is nice because it's sort of the standard Java way, right, where all of the normal APIs still work, but you have a couple new APIs that give you all the same primitives to work with. So, excuse me. I was saying earlier that there's a lot of thought that went into this feature, right? And what I don't think a lot of us realize is that over the years, they've sort of been working towards getting this out, right, underneath the hood. So if we look at what's happened over the last few years, the JVM internals have slowly been reworked to basically ensure that virtual threads work. So the thread API obviously is changed. There's been changes to Java Util Concurrent, Java Net, Java NIO channels, Java IO, all these different areas that are part of the JVM. The debugging tools have been updated. There's been a few other JEPs along the way. So in JDK 18, they re-implemented the core reflection with method handles. And this allows virtual threads to park gracefully when methods are invoked reflectively. So this is an underlying change. JEP 353, they re-implemented the legacy socket API in JDK 13. And in JDK 15, they replaced implementations of the socket, service socket, datagram socket classes so they work with virtual threads. And what's great about this is all this isn't going on under the hood, but like most of us didn't notice, right? Everything has continued to work fine, which is really, really nice. In JEP 418, they changed the init address feature so that resolvers don't pin threads during host lookup, which is obviously very important. And so that's a lot of sort of what's happened over the years. So in terms of actually getting stuff to work, well, let me take a step back here. Okay, so we have all this groundwork, right? And you saw that you could very easily write some code that use virtual threads, using the thread API, using the executor service, etc. Right? But the reality is most people don't actually write a lot of code using those low-level APIs, right? We write code using high-level frameworks like Spring or Jakarta EE or something else, right? Or MicroProfile, Quarkus, Helidon, whatever. So the question is, well, how can you get the support, right? Because the idea is that you can basically give your application, access to increased throughput with a small amount of effort, which sounds like a panacea, right? So how can you do this? So it turns out that the servlet servers and web servers actually have support at this point in time, and they actually had it as of early this year and late last year. So with Tomcat 10.1.1, which came out this year, all you have to do is configure the standard virtual thread executor. So if you're using Tomcat, you can just turn this on and voila, you get virtual thread support. And this is because the low-level APIs are so simple to use, right? So all they did, there's a thread executor used that's configurable in Tomcat, and they just gave you the option to use the virtual thread one. Jetty 10.2 or 10.0.12 and 11.0.12 have virtual thread support as well, which you can configure. Also, Netty currently does not have support. They've been talking about it, but it's not something they're really that interested in. Undertow, nope. So if you're using the reactive ones, there's not really as big of a need, right? Because they already have a lot of those features, right? They already have the throughput and everything, and they're probably using the reactive APIs anyways. But if you're using a more typical web server or web container, you have support. So then when it comes to the actual microservice framework, what's the deal? Quarkus has had support since 2022. And what they've said so far is that the performance is almost as good as reactive, which is nice. They have a guide that you can take a look at. And this is what it looks like for Quarkus. And with Quarkus, they have an interesting approach where they basically just say, run on a virtual thread. That's basically the difference. And you'll notice that, of course, the return types are normal Java types. There's no fancy reactive stuff. This is just normal Java code. Nothing special going on here. And this is an example of doing it via using Mutiny as well. Now you'll notice here they have actually that's the async method. Okay, I lied. All right, so you can do it pretty easily there as well. By the way, if you have any questions, you can just ask now. We have about 10 minutes left. So, all right. So Helidon is adding support by the end of this year. And what's nice about Helidon's approach is they had Netty, right, which they were using for their sort of reactive engine. And they're actually replacing it with a new web server called NEMA, which is built from the ground up using virtual threads. So to me, NEMA is a very interesting project just to look at in general, even if you're not interested in Helidon. Helidon is Oracle's open source microservice framework that supports microprofile as well. But what they're doing with NEMA is very interesting. And actually, I will point out what's interesting. I listened to a podcast about this, and they're like blown away with how much less code is required for NEMA than all the stuff they had to do with Netty, excuse me. So Micronaut as well, another open source microservice framework, is supporting it this year as well. And the Spring Boot, with Spring Boot 3.2, you can just turn on with a simple flag, which is nice. With prior to 3.2, if you're using Tomcat, you basically just have to turn on that virtual thread executor. And also what you want to do is tell Spring to use the new virtual thread per task executor as well, because Spring will also create its own threads as well. So obviously upgrading 3.2 is the easiest thing to do, but you don't have to. You can still do it with older versions. Okay, in Jakarta EE, they're looking at adding support in Jakarta EE11, which should be out sometime next year. So hopefully that'll be out for Jakarta EE as well, and that will affect, if you're wondering what's inside of Jakarta EE, that will affect like Jakarta REST. So anything that uses JAX RS or Jakarta REST would also get support. And then of course, I don't know that there's anything required for servlet, but there may be. So at the servlet level, if there's anything that needs to be changed, that can be changed as well. And then of course, things like CDI, context and dependency injection, and EJB, for those who still use it, they may take advantage of it as well. So one of the key things here, though, is that you can use all these virtual threads, but if you still have code which blocks somewhere, you have an issue, right? And what's interesting is you find this often with JDBC drivers, right? So if you've written reactive code, you'll find you need to find the reactive driver for whatever database you're using. Otherwise, it's going to be blocking a lot. So basically, you need to make sure that if you are using any third-party libraries, that they don't block, right? Or at least, and the easiest way to do that is to find out if they've been upgraded for virtual threads. That's pretty much what you would look for. Hi, Brian. All right. So Oracle has upgraded their JDBC driver for Oracle the database. So that's been updated. But if you have another driver, you'll have to make sure that you actually have upgraded appropriately. So you want to see if that driver has support. And this goes true for any other framework or libraries that you use. So if you need to talk to other services, if you have, if you're using Amazon libraries, if you're using whatever you're using, try and see if they have support of virtual threads, because you may find that you end up pinning threads whenever they go into that particular third-party library. So something to keep in mind. So even though you at the application level can very easily sort of magically, turn on virtual threads, you're only as scalable as your weakest link. So, all right. So that's pretty much all I have. Here are some links for you, and there's a lot of great articles on there that you can take a look at. If you have any questions, you can put them in the chat. I'll be happy to answer them. Take a note. Okay, looks like we don't have any questions. Okay, thank you, David. I should mention actually something else I forgot to mention is that Project Loom is not over. So the first step was the virtual threads, right? That's sort of the main thing. But another thing which that's on the horizon is structured concurrency, and there's actually a JEP for that now. And structured concurrency allows you to sort of structure your calls so that at the end of the day, your stack trace is readable. And now I should take a step back. That one of the benefits that virtual threads does give you is that the stack traces are automatically readable up front. But structured concurrency gives you a way to sort of provide a reasonable sort of structure to all of your calls, which may not be called concurrently or synchronously, I should say. So I would definitely suggest you take a look at that as well. So, all right, I think that's it. So thanks a lot for coming. And I encourage you to stick around for JCon. There's a lot of more great talks today and tomorrow. So thanks a lot.